Hey everyone, we've got Paul Ihme from Soteria, and he's going to be speaking on detectors as code.
All right, I'm going to try to do this without a mic because I don't like using mics, and I'm also going to try to speed run this presentation, so hold on to any questions till the end. Real quick, my name is Paul Ihme. I'm a co-founder of Soteria. My background, I've done some work in the Air Force, offense at the NSA and Cybercom. I've worked at JP Morgan and IRS in their defensive units. Also can really operate an edger and make a mean chicken tender if anybody wants anything like that. But in my career, I've done a lot of offense, defense, and special teams, GRC type of stuff. So I've kind of been around the block and done a lot of different stuff. But today we're going to talk a bit about detection engineering. So just setting the stage real quick for what is detection engineering. To me, it's really about going and trying to find the capabilities that you need to build in order to find bad things happening within your environment, right? So it used to be that you would go buy, whatever McAfee's selling at the time, install their antivirus and hope for the best. Throw a firewall in and you can go at it. But for the last 10 years or so, between EDR tools, SIMs, NDR tools, those types of things, you can really build very customizable tools that are very unique to your environment and can meet your needs. So to me, detection engineering is about figuring out what's out there on the market, going out, procuring those tools or installing them, customizing those capabilities, building your own rules, detection logic, so on and so forth, testing, verifying that to make sure that they work in your environment the way that you want them to, maintaining them to keep up with threats, and then when things don't make any sense from a cost-benefit analysis anymore, you get rid of them and go on. So it's a life cycle, and it's something that we have to keep up with. But I want to talk about detectors as code and the way that we do detection engineering at Soteria. So we do a lot of MDR work, managed detection and response, where we're doing this on behalf of our customers. And in order to make this scale, we have to do a lot of this via code, right? So first and foremost, why don't we just use the GUI, right? And these are the reasons. These are the things that I've seen over and over again as we looked into different security operations centers or looked at different people trying to defend their networks. You have people who just kind of log into their SIM, they write a query, they think this is a good query, I'm going to save that and make it a detection capability, or you can do the same thing via EDR or whatever. And you're left with a lot of questions. One, you don't really know what you have, right? You've got a lot of people who are going in there and saving rules, creating new queries, but if somebody said, hey, can we detect X, right? Can we detect this new Microsoft Folly Beach exploit that came out earlier this year? Everybody's kind of looking around at themselves and maybe we can go and look at the list of queries, but there's no real core base of knowledge of what the capabilities are in a given organization. Another one is you have no idea if these rules really work, and that's really tricky in a lot of environments, right? You write a query, it comes back with nothing, and you're like, well, did we just not get popped? Or is this a bad rule? I don't know. So there's no real rigor around trying to figure that kind of thing out. Or the opposite can be true. You put in this new detection capability, and then the next thing you know, your SIM's flooded because you've got 10,000 hits coming in a second because you accidentally wrote a rule that will detect on any new process that's launched within the environment. And this has happened, right? Another thing is like mysterious alerts. So you have some genius, SIM engineer who writes her rule and saves it, and then an alert fires in the middle of the night, and your overnight analyst gets the alert and says, "What the hell do I do with this? I don't know what this means. How do I investigate this?" And it's pretty much worthless in that sense. Or somebody goes in, they make a change to a rule, and it breaks everything, but nobody remembers what it was like before, and you're just kind of left there stuck looking at it, right? So this is why we take a detectors as code methodology, right? You want to be able to track requirements from a detection standpoint, from where did this requirement go to how did it get implemented, and vice versa. What is this detection? Can we track this back to the requirement that made it exist in the first place? Having source control, using developer tools like Git, will allow you to have a full history of that detection capability from the time it was first created, every change that was ever made, and you can attribute each of those changes to individuals within your organization. You can establish coding and documentation standards. That way you make sure that when people create these new capabilities, you have documentation to go along with it. That way it survives past the mind of whoever created it in the first place. You can do some unit testing, and you can do some continuous delivery type of stuff. So all of this is really trying to implement these capabilities that software engineers have been doing for years, right? Like CI/CD is the buzzword that everybody uses, and usually people are doing continuous deployment, not necessarily integration. But the software engineers have been doing this forever, and there's no reason why your security operations team shouldn't be doing the same thing, because it works and it fixed a lot of problems. So we're going to talk about our approach, how we go about implementing detectors as code at Soteria, and we're going to talk about, we've been doing this for 5 years and we screwed up a lot. So we're going to talk about some of the things that we've learned along the way and how we've gotten better over the years. Right? So, real quick, just talking about our detection lifecycle. So, this is a little bit oversimplified, but at a high level, this is how it works. Right? First, you have on your upper left, you have a new detector issue. So somebody's got an idea, or I read this thing on Twitter, or Mastodon now, I guess, or some offset guy, came up with this new technique that he wants to know if we have a capability for. So you say, hey, we got an idea, can we detect this? You go and research it, say, nope, let's take a look. Then that gets passed over to your detection engineering team, so they can go out and build this detector. And that may mean using tools you already have to write a rule. It may mean going out and procuring some new technology to fill that gap, or some combination, or changing the way you look at it. But you have to figure out how to develop this logic and this capability within your organization. And then you're going to do testing, right? Because we're not going to put anything in production without testing it, right? So we're going to find a way to test these new capabilities against some sort of telemetry that we can generate to make sure that it works the way we want to, and to make sure it's not ultra false positive prone, so it's not going to flood your team with a bunch of noise that's not useful. Then you can deploy it, and you're going to learn lessons once you actually deploy this in production, because nothing ever works in testing like it does in production, and it's going to just go around in that circle, and you're going to continue to refine these things. So, phase one, submitting new detectors, right? The way that we've done this is we just use Jira, right? Because we're trying to mimic the way that software engineers do this, and really we just want a few different things. One, what are we trying to detect? What should we be looking for in this detection capability? We want to have some labels and tags just to make it easy for us to categorize these things and report on them. That's easy. And then links to reference material where we have them. So going back to some of our lessons learned over the years, we used to have a whole lot more stuff that we would ask for when somebody submitted an issue like this. And really, it's just a barrier to entry, and nobody wants to write all that. Who can be bothered with doing all this research, right? We were asking people to go ahead and put all the MITRE attack IDs in there that apply to this. Tell us about all the potential false positives that might be able to come up. And it's just, nobody wants to do that, right? So we have offensive security folks. We've got security advisors. We've got people who just read blogs. And what we wanted to do was create it in a way where anybody could go and just submit an idea and have a very low barrier to entry. That way we could go and triage it. Another lesson that we learned is when we first started this, we just did this for new detection capabilities. And what we quickly learned is we're going to be doing a lot of tuning, a lot of changing to existing rules. So we actually created templates that are very similar, but also apply to tuning existing detectors. That way, for our security analysts who are actually triaging alerts on a day-to-day basis, they have a very easy way to go submit this back to the detection engineers and make sure that they get the information they need. So they can also go and link to hey, we get all these false positives. Here's some deep links into our tooling for some example events that we don't want to get alerts on anymore. Can you go fix this? Makes it very easy. And then finally, we started using, you can see the create branch and create pull requests. We started using smart commits in GitHub, because it allows us to link back to this Jira project. That way, if somebody wants to know what is this pull request actually trying to achieve, and who requested this thing, it makes it very easy to just go map these requirements back and forth. So that's really what this is all about. The first time you go through a SOC 2, if anybody's ever done that, that's what your auditors always want, is this audit trail from this requirement into production. So we started mimicking the same processes that our engineering team used to apply to detection engineering. Phase two. So now we're going to go develop a detector. And in a 1 hour long version of this talk, I would go through and actually create this in real time. But since we've got 30 minutes, these are the fields that we demand that have to exist and be well defined in each one of ours. And I'll go through this. You need an ID We'll have a status, right, that can be archived for capability until we retire. Some things are just in that testing phase, so we're not going to push these out to all of our customers yet. We're just going to do it in a testing environment. Or active obviously means, this is out there. Description, this is, again, one of those things that makes this useful to people beyond the person who actually wrote the rule. Having a human readable narrative description of like, hey, here's what this thing is looking for and why it matters. References, right? If you've got blog posts or tweets or toots or whatever that you can point to where people are talking about this, make sure that there's like good reference material, because you don't want to write a whole blog post in your documentation here. MITRE attack mapping, because obviously, and then investigation and response guidance, right? So if your most junior security analyst gets this alert in the middle of the night, what do they need to look at? How do they investigate? What are some common false positive scenarios that might exist that you've seen? When do you escalate this to a more senior analyst, or is this something that immediately escalate and start your on-call process? So making sure that if somebody gets this and they've never seen this detection fire off before, they at least have a place to start and they know what to do and they're not left in the dark. Some general notes for things that don't really fit neatly into any other categories, the actual detector logic, and then verifiers. So we're going to do our unit testing, which is what we want to talk about next, right? So, unit testing for anything that we're going to put into production, we want to know, does it actually detect the thing that we're trying to detect? Does it detect unintended behavior? And then is that unintended behavior going to be so noisy that this becomes useless, right? Is it going to be resistant to super high numbers of false positives? And then is it resilient enough to withstand behavior evasion tactics, right? If you just change the camel casing of this command, is it just going to break everything, right? Is this detector looking for commands being run on in a specific directory? Or if you change the name of a binary, is it still going to fire? Or if you change the port that you're using to do this command and control protocol, is it going to bypass? So making sure that you have these capabilities to bypass that and test it automatically. So some lessons learned here. I mentioned the old alert that fires on every new process. Yeah, we've done that. So that's something that we learned very early in the process, right? Is every detection for any type of activity should have a very generic false positive test of like, here's just like some process launching, and if this process launching fires this detector, then that's bad, get rid of it, right? Another thing that we learned is that you can't really spin up, I mean you can, and we did for a while, but like spinning up containers to run Atomic Red Team or Caldera or whatever every time you want to go build something, super time consuming. And then after you start doing this at a high enough scale, it takes hours to go and build and deploy new rules to your customers, and that's not going to be acceptable. So you really have to shrink that feedback loop and make sure that your detection engineers can really test and understand that their things are working as quickly as possible. So one of the core tools that we use on in our detection platform is Lima Charlie. So they're a sponsor today. These guys are great. If you didn't talk to them, you should have. But they have some really amazing capabilities where you can do replays, right? Which is roughly the equivalent in a SIM of being able to search against historical data and see if your queries are going to hit on anything. But what you can also do is you can copy out raw event data from the Lima Charlie platform in JSON format, save it to a file, and then say replay this rule against a series of events and tell me if it's going to fire or not, right? So that's what we started doing within our detection engineering practices. We can go and we can work with our offensive security team, or we can go and pull real data from a client where we detected some weird thing that we'd never seen before. We can pull that event data, anonymize it so we're not having actual usernames and IP addresses in there, save it within our detection, and then every time somebody makes a change to this detection, we can say, hey, this should hit every single time. So if somebody goes and puts in some sort of tune request and it causes this detection not to fire on this event, then it's not good and it needs to fail that unit testing and not be built. So what we ended up doing, even still, we had to do a pull request every time we wanted to test something because this was part of our build pipeline, and this continued to cause frustration for our detection engineers. So everything in Lima Charlie is done via an API. So what we did is built a VS Code plugin, which is where we write most of our rules. And we just built a VS Code plugin to go and look for these unit tests and to actually validate these right there on our developer's workstation. That way it takes them a couple of seconds to actually get this feedback. So in this example, what we wanted to do is do some linting and format checks to make sure that it wasn't going to get some weird syntax error, and now they've wasted 30 minutes, going through the build pipeline for nothing. Leverage the Lima Charlie replay API to execute these rules, and then capture benign events to prevent any sort of untunes, right? So in this example, you'll see, and it's kind of weird, but this event here in line 276 in this detector that we wrote is named Okta device registration false positive event. So this is something that we were seeing in one of our clients' environments. Every time Okta registered a device, it would create a false positive for this particular rule. So we captured those events that caused this to fire, and we said this should never fire, and we can put these unit tests. For the purposes of demonstration, and again, I would have done this live if I had more time, but I changed it to true, so saying that this should fire. And now when we run our detector buddy, very cleverly named, when we run our detection engineering tool, it'll go through all these verifiers, say verifier pass, and it goes on down to the bottom, and you'll see this verifier failed. And then using the Lima Charlie API, we can print out at the bottom, and you can't see the whole thing, but we can say this came back as true, this came back as true, this came back as true, and this came back as false. So it's a nice debugging tool for our detection engineers to be able to look and say, okay, here's the faulty logic that I need to fix in this tool. So again, this is, it's just all about, it's the same with developers, right? If you're a software engineer, you just want to be able to get your feedback loop going as tight as you can. That way you can fix things and move on and not spend time waiting on something to build. That way it can fail and then you have to go back and try it all again, right? Then phase 4, finally, we get into the automated pipeline. So once all this is done, then we want to push the detection out to the detection platform and get it out there going. So this is really just a summary of everything that we talked about. So right there on the left, this is a flow chart of our entire process. You start out with your threat intel from your offensive security, your threat intel team, or wherever you find things. That idea gets put into Jira, passed off to detection engineers, where they will commit something into GitHub using an issue branch, because we never commit directly to main, right? Via smart commit, that's going to be linked back to Jira. That gets put into a pull request. GitHub Actions will do all this automated build to go and do all of our unit testing, make sure it's compatible with the platforms the way we think it is. If it passes that unit test, it goes to peer review. We want other detection engineers to take a look at this before we push it into production, because nobody's allowed to go into production by themselves. They can approve the pull request, and then from that point it gets merged into main. In this case, goes straight into using the Lima Charlie API, gets pushed out to all of our customers, and then we're off and running. And then all of this, feeds back into Slack, because of course everybody uses Slack to know whether anything's working at any given time, right? So I think I got that in just in time to have some questions. Any questions?
When you're generating your rule sets, how do you understand if you have a blind spot at large with the collective set of rules that you built? How do you go and minimize that blind spot?
Yep, so the question was, how do we find blind spots in our coverage, and how do we minimize it? I think there's a couple ways, but really a big piece of it is MITRE attack framework, right? That's like kind of the go-to. So we mentioned in our detector template, we're going to map every detector to the MITRE attack techniques that applies to. And during that build process, another thing that does that I didn't mention is that will actually build and update a dynamic MITRE attack tree that you can go and browse to and see what the coverage is. And you can see all the reds, greens, and yellows, and whites where you have no coverage. So that's one piece that's very easily visible. A lot of it is working with customers who are going through pen tests and just like being very like collaborative with them to say, hey, we found this thing, and they're like, oh, this is a pen test, and we say, great. Once you're done with that pen test, can you like tell us if they found anything that we didn't alert on, and like let's work together to figure out why. And one of the things that we've had to come to terms with, and I think every security operation team does, is like you can't detect everything, right? So you have to just be okay with that. Like you can't detect unauthorized logins, because how do you know if this is unauthorized, right? So you're going to have gaps. You're going to have MITRE attack techniques that aren't covered, like deleting a file is a MITRE attack technique. If you detect that, then you'll destroy, your team. But but that's really how we do it. So just a combination of using like those known frameworks and working with our customers, and then we have an offensive security team that likes to kind of poke at us and like make fun of how bad we are at our jobs, and then we can tell them the same thing. So we it's kind of that competition and going back and forth of saying like, hey, can you guys detect this? And hopefully we say yes. But if not, then we can say, oh, well, let's go set it up and do some testing and put together something to see if we can work out a good way to do that.
Actually, this is a new event generation object.
Mm-hmm.
When you're using tools like Sigma and other things, and already pre-built rules, like optimized rules, do you guys do anything like that, or are you?
We do not use Sigma, and we don't pull in pre-built rules, but we definitely look at them for inspiration. So there's a lot of Sigma rules that we have pretty much one-to-one like equivalents of already. There's some that we'll we look at their GitHub repo and we'll say like, oh, that's a good idea, but they do a lot of things that we don't do, right? We really optimize to make sure that we have when we look at this, we try to look at attack chains and say, can we catch this somewhere? And we understand that we're not going to catch it everywhere along the chain. And I think Sigma has a lot of like, let's catch everything along the chain in a lot of cases. So we try to make sure that we're not getting too much, like try to optimize against false positives. But we definitely look at that, and we're like looking at Elastic publishes a lot of rules. So we'll look at those, and we make our rules available to people as well. So we look at that sort of body of work and see what's out there, more for inspiration, but we don't automate anything because fun story, we used to do a lot of network detection, and we used the what's proof points threat feed for emerging threats, and like if you've ever done that, like tons and tons of rules and tons of noise, and that's what we were trying to avoid. Is we want to have very very tight control over everything that goes in, and we want to know that we built it and we understand everything, and not do any sort of automated rule generation that we don't have that deep understanding of.
I agree with you, because when you're looking at, those of you that don't know what emerging threats is, Tor has a rule set that's got 60,000 alerts to detect everything from, 1990 going forward.
Right, yeah.
But the problem is going through all that data sets and mapping into MITRE helps, but all that's mapped to CVEs. So
Yep.
mapped to anything useful.
Yeah. Yeah, and a lot of what we focus on too is behavior based, and this is another talk, right? But going into a new CVE coming out, right? A new yet another exchange exploit. If you're going to be looking for that, there's more generic ways to look at it, like looking for shells spawning from IIS processes and things that will catch every iteration of that, or IIS processes writing ASPX files and things like that. So you can do like generic detection capabilities where these new exploits come out and you look at them and say, hey, we don't have to write anything else because we already have coverage for that just by nature of this behavior-based rule. So that's a lot of what we focus on, is not trying to detect like the CVEs, to your point. Like that's what a lot of emerging threats is can I find this byte pattern that matches this exploit? So we try to avoid that because it becomes too fitted to the problem.
So would you say that most of your detections are high fidelity and less investigative?
Yeah.
What percentage would be high fidelity versus investigative, forced investigative?
I would say probably 60-40, like high fidelity. Like we totally have some like stupid rules, like looking for a certificate that's signed by Benjamin Delpy, right, who created Mimikatz. And those are really signature-based rules, and those are super high fidelity. Like if you see that, that's always bad news, unless it's like a pen tester on your own team. But we do a lot of things that are, strange, like binaries running out of weird paths that they should never be running out of, and strange, somebody running whois as system, right? So those types of things is like, this could be okay, but it could also be very not okay, and that's when having like this documentation that says like, here's what to do and how to investigate this alert really comes in handy.
Do you have detection relationships?
Yeah, so we have some that like, a good example is like RDP. An RDP connection from a public IP address is like a low priority issue. Like, you should probably not have this exposed, but you know, it's not necessarily something bad. But then the same rule, but with a successful login, is is worse. And the same rule, but a successful login and it came from Bulgaria is like worser. And then like it kind of escalates and builds on each other like that.